So for number 13, the fastest way to do this problem is to remember your change of base formula. Change of base says that if you have something like log base b of x, that's equal to log of x over log b. It's a way to use your graphing calculator. Since your calculator only has log base 10, change of base changes it into the common log. So for number 13, what I would do if I were you guys is change this into log of 4x over 4 divided by log 4 plus log of x plus 3 divided by log 4. And then I would see where that intersects 2 in my graphing calculator. So in my calculator, I go y equals, I'm going to plug in log 4x divided by log 4 plus log of x plus 3 divided by log 4. And I would see where that intersects 2. When I graph it, I get a curve that represents the logarithmic portion of my, and I get a line. If I hit second calc intersect, enter, enter, enter. Oh, needs me to change my curves. There we go, and guess. I get the intersection is that x equals 1, y equals 2, which tells me for my answers that x equals 1 works. You could also do this problem by guessing and checking. If you plugged -4 in for x and then used change of base, you could see if it gave you 2. And then you plug 1 in and you see if it gives you 2. And if you did that, you would see that the only one that works is 1. Okay. On number 14.
Wait, just a quick double check for number 13.
Uh-huh.
Doesn't the log base 4 cancel out the 4 on the x?
You would have to separate it out using your log laws that we did in that investigation. So you'd have to break it out as log base 4 plus log base 4 of x plus log base 4 of 4. You'd have to separate it, and then you could do some canceling. But it doesn't just auto cancel that and leave you with x.
Because I did that and it still worked.
You probably didn't do it correctly. Gonna put that out there. So number 14. The easiest way to do number 14 is to go one at a time and graph them and see which ones give you the correct xy points in your graphing calculator. So what I would do for this is I would plug in 4x to the 7th, and then I'd go in my table and I would see if I get the point 128. I don't, so that doesn't work. Cross that off. Then I would plug in 7 times 4 to the x power, and I go in my xy table, and I would see if that gives me 128, and it does, and it gives me 112, so that has to be my answer. Thank God for graphing calculators. Okay. Number 16 is also a graphing calculator problem. Whenever you want to solve, when in doubt, graph it out. So in my y1, I'd plug in 2 to the 3x plus 1, making sure to put parentheses around the exponent. 4 to the x plus 5. I would graph it. I get 2 exponential curves eventually. It takes my calculator a while to think about it. And then I would hit second calc. I would go to intersect because I want to know when they're equal. Enter, enter, enter. And they intersect at x equals 9. Since this problem is asking me to solve for x, my answer is x equals 9. And in a problem like this, you would just put a 9 in the far right, and then you would bubble 9. So if you guys, on the SAT and the ACT, there are some short answer portions, and the way that you enter your answer in is you just put the number in and then bubble what your number is, what your answer is.
How do we know which column to put in?
You just fill it in far to the right. The same way that you would like, I mean, if I put it 1 over, that would be like 90, right?
Oh, yeah.
So it's like 1's place, 10's place. Okay. And that's it for chapter 7.